Hi everyone. So today I'm just going to give a quick 10-minute or so tutorial on the independent or unpaired t-test. So this is one of two main t-tests that you can run. So I'll go through the definition, a couple of the assumptions that are typically required that most people actually ignore, but it does have some assumptions for the test. And then how you'd input the data into SPSS and how you'd run the test and how you'd interpret the output as well. So this is a test just to compare essentially two means to one another. And these are means that are typically unrelated. So if you had two groups of people that you took a single measurement from, then you could run this test on that data. And there are two main assumptions. The first one is regarding equal variance. So this is to check if the standard deviations are essentially equal between the groups. If there's quite a lot of variance there, then typically that assumption will be violated, and you can run another test called a Welch t-test, which doesn't have this assumption. And then the second assumption is a parametric one, so does the data follow a normal distribution? And if not, you can run the non-parametric equivalent, which is the Mann-Whitney U test. So I'm going to run through all of these alternatives so you can see how you'd run each one and when you'd need to do so. And then sample size is also a factor. I'm not going to go into this, but it's just something to consider. If you've got a very large sample size, people would just say run the t-test regardless. The more people you have, the more data you have, the higher the sample size, then the more power you have anyway in your test. So let's just look at an example. So this is just some made up data. So basically what I've done here is just devised two groups, and I've measured resting heart rate in both groups. We have 3 people in each group, so there are 3 people in group 1 and then 3 separate people in group 2. If you had the same group measured over time, day 1 versus day 2, then you could run a paired t-test or related t-test because those samples are related to each other, but these ones are independent. So these are different groups but same time. And then you can break it down this way. So you've got 3 biological replicates in each of the 2 groups. And then if you plot this data, you can see, just looking at it, that group 2 has a higher resting heart rate than group 1, but we don't know if this is significantly different. And this is when you'd run the independent t-test. But we want to check the assumptions first. So first we can check equal variance and then normality. So this is the workflow that I would typically do. So check the equal variance. This is actually included in the output with the independent t-test. So you can check normal distribution first and then equal variance. And then depending on what we find, we can then choose the most appropriate test depending on those initial measurements. So do we run the independent t-test or do we run a Welch or Mann-Whitney U test? So in order to put this data into SPSS, we can essentially just create our variables and copy and paste this data in. So this is our data, but first we actually need to set up our spreadsheet in SPSS. So I'm just going to do this. I'm not going to run through each step per se, but I'll just show you how to do it. So first of all, we need a scale variable, which is where we're going to put our heart rate data. So we can call this resting heart rate if we wanted, or anything else. That makes sense. A resting heart rate. You can't have a space here because it won't allow it. And then this is a scale variable. It will automatically set it to scale if you don't do it. So that's important if you need a nominal variable, which we do. So we can call this one group. This is our nominal variable. And then we need to label this and put some values in. So we can say value 1 equals group 1. And then value 2 equals group 2. And then press OK. So now we've got our spreadsheet set up how we want it. It's got our scale variable and then our nominal variable. So 1, 1, 1 because we've got 3 people in that group, and then 2, 2, 2 because we've got 3 people in that group. And then we can go to our Excel. We can just copy and paste our group 1 data. And then we can do the same with our group 2 data as well. Okay, so now we can actually run the assumptions. So the first assumption that you would typically run would be the normal distribution, and for this it's the Shapiro-Wilk test. So to do this, we'd go Analyze, Descriptive Statistics, and Explore. Group is our factor. Resting heart rate goes in our dependent variable box. And then we go on plots. So you can turn on and off whatever you want here. I've actually done this recently, so it's saved it. So anyway, we need to click only normality plots with tests and then press OK. So you always get more output than you need in SPSS, but we want this box, tests of normality. So you have two measurements, the Shapiro-Wilk, which is typically for smaller sample sizes, like less than 50. We've got 3 in our groups. This Smirnov test is typically for larger sample sizes. So here we're looking for higher than 0.05 or 5%, and these both are. So if we had 10 groups, we'd have 10 p-values. But here we've got 2 groups, so we've got 2 p-values. So this assumption is met. They're both higher than 5%, so that's good. So the data is normally distributed. And if you wanted, you can look at your QQ plots as well. So now we need to check the equal variance, but that is included in our output for the independent t-test. So we can just run the test and then examine both the output as well as the results. So for this, we go analyze, compare means. And because we have independent samples, we have to choose the independent sample t-test. And for this, we want to put our scale data into the test box. So that's our resting heart rate. And then our grouping variable is group. This is what defines our group. So you've got to click on define groups. Group 1 is 1, group 2 is 2, continue. Now this box is highlighted so we can select it. And this is the box we want. So independent sample t-test. Here, it gives us our Levene's test for equality of variances. So this is our homogeneity of variance test. And here what you've got is basically a p-value that represents all of the levels within that group. So if we had 10 groups, we'd only have 1 p-value. It's not like the Shapiro-Wilk test where you get a p-value for every level within that factor essentially, but here we just get 1 p-value regardless, but we're wanting it to be higher than 5%, and it is. So 0.302 means this assumption has been met, and we can look to the right and we can see that on a two-tailed test it's 0.025, meaning that this mean difference of 36 beats per minute is significantly different. If we didn't have equal variance, it also gives us another p-value. So this is quite nice. If we didn't have this equal variance measurement assumption met, it would still be significantly different, but we can see that p-value is slightly more conservative. So if this was 0.06 and this was 0.025, then you'd have a decision to make. Do you then run the Welch t-test, or do you log transform the data or something like that? So we can actually do the Welch test now, just so you can see how we would do it. So for that, we go to analyze and we go compare means. And it's a bit weird because we've only got 2 groups, but we can essentially run a one-way ANOVA, which is typically on more than 2 groups. And if we put resting heart rate in our dependent variable box, group as our factor, and we click on options. I've already selected this earlier, so I've got Welch test ticked, and if we click continue and OK, what happens here, and it's quite nice, we have the ANOVA, which gives us a p-value of 0.025, telling us that there's a difference between the 2 groups. And you can see it's exactly the same p-value as here. And then it gives us our Welch, essentially a Welch ANOVA, is 0.042, which is the same as what we get here. So it's giving us the exact same results. It's just another way of getting to the same output. So the last test would be the non-parametric t-test for independent samples, which would be the Mann-Whitney U test. So we can click analyze, non-parametric independent samples, and I'm going to reset this just because I've already done it. So you would start from this screen, so you'd have to go fields, resting heart rate goes in test field, group is our grouping variable again, settings, customize test, Mann-Whitney U, run. And now you get your non-parametric output as well. For this it's different, it's telling us that it's 0.1. I think this is because we've got quite a small sample size as well, but it's not as much power, I don't think, as the independent test. So here it's saying there isn't a difference between the groups, whereas before it was saying there is a difference, but our data is normally distributed, so we wouldn't typically run this test. We'd still stick with this independent t-test output. Okay, cool. So hopefully you found that interesting. For the next video, I'll do a paired t-test, so you see that's actually slightly different, even though it's still comparing just 2 groups. And if you found it useful, you can hit the like button and subscribe for more videos. All right, thanks guys.